Hi everybody, this will be part 21 of the character rigging tutorial series. In this video we're going to talk about an overview of how to set up controls once you have created the joints and applied the geometry to the joints through the skinning process. So now we need to create custom controls that allow us to move and animate the joints in a natural and easier way. So controls are set up to be able to make the animator's job more fluent and easier, as well as allow the body to move in as natural way as possible. One thing we could do is just animate the joints directly, but some of the motions that we'll need, such as like jumping, bending down, kicking, stepping, walking, pushing off of a wall, holding a weapon, cannot be done by just rotating joints in the most efficient way. So we use controls to make our life as an animator easier and always to allow for more natural motion. So the controls will be set up to drive the motion and, as the word says, control the joints. The joints will drive the motion of the geometry. So this video will talk about some key terms, and I'll go through some demo setups of how each one of these different things can work. So over here on the left I have an example of a joint. We've talked about this before in previous videos. So after you have created the joints and then skinned the geometry properly, now we're going to create the controls. So we do need to go back and kind of review what a joint looks like, as well as the important parts that will help us be able to rig the controls set up properly. So the only thing really to understand is how we create joints. The original rotate position of the joint. So if I get the rotate tool, we need to know the original rotate angle of a joint, as well as we need to know where the pivot point of that joint is, which is how that joint rotates. So this is a single joint. Underneath that I have a joint chain, parent to child relationship hierarchy. This would be the base joint. The tapered pyramid always points to the child joint. So this second joint, we could say this is like an arm. So this could be a shoulder, elbow, and then wrist. So the shoulder would drive the motion of the entire arm. The elbow is a child of the shoulder joint. The wrist would be a child of the elbow joint. So that's what we have talked about in previous videos of what a joint is. But it's important to kind of review and understand the angles of what's important for a joint, the rotate angle and the pivot point location. So some other terms that we'll talk about in this video and as we rig a character up is what's called an inverse kinematic. So I have a couple examples of forward kinematics and inverse kinematics that we'll get into more detail here in a little bit. But just to show you, forward kinematics are called FK. Forward kinematics are where we are rotating each individual joint one at a time, or using a control to rotate each individual joint one at a time. So for instance, we have forward kinematics for the arm. When I rotate the shoulder, then I rotate the shoulder, then I would come animate rotating the elbow, then I would come animate rotating the wrist all the way down to the fingers. So that's called forward kinematics. You usually would start from the root of that joint system, in this case the shoulder, and then work your way towards the end or the fingers. So that's what's called an a forward kinematic system. This over here is what's called an inverse kinematic system. We shorten that to IK. So an IK or inverse kinematic is where we use an end effector to drive the motion of more than one joint. So say this would be the shoulder, the elbow, and the wrist again. I have one control, whereas in forward kinematics I had a shoulder, an elbow, and a wrist control, so 3 controls. But in an inverse kinematic, you only have one control to move the main parts of the arm. And with the inverse kinematic, when I move this control, it moves all 3 joints. Okay. So what this is useful for is when a force is applied against that body part or that object, that we need to move more than one joint with one control and apply a force against that. So this works really well for legs when we're stepping, kicking, sitting down, bending over. This works really well for arms if we're doing push-ups or picking up a heavy object or shooting a weapon that we need to hold it with 2 hands. There's a lot of different scenarios where we would need inverse kinematics, We could also use inverse kinematics on tails and wings. We can use inverse kinematics on like cranes or mechanical objects that need to use a rotate based motion, but also for more than one joint. So this is what an IK looks like. We actually have the joints visible as well. The IKs are going to be created where we're going to be skipping one or more joints. So in this IK, we're skipping this middle joint here. If I turn off my joints, this is what the IK looks like by itself. It is an orange crosshair with a straight line. So that's in contrast to the blue joints. So the IK will look like this. When it is selected, it'll show you that another set of lines that will cross over the joint that we are skipping. So let's turn our joints back on. So when I select my IK and move that, that gives me the opportunity to move more than one joint at one time. So that's what's called an IK or inverse kinematic. They are orange type controls. The one underneath that is what's called a locator, and the one underneath that one is called a curve control. So the reason we set up controls is to allow us to animate the character or object in a more efficient way. And the joints are inside of the body if this is a character, which makes it difficult to select the joints. So what we typically would do, we'll create other controls that will allow us to select the joints and animate the joints when we're outside of the body. So one opportunity for that is a locator. A locator is a green crosshair, and it doesn't have any dimension to it or thickness, so it's not going to render. Inverse kinematics will not render either. Joints will not render either. Just the geometry will render. So that's why we're using these specific types of terms and tools within Maya. But a locator is a green crosshair, and that gives me the opportunity to drive the motion of a joint or an IK in an easier way. Another opportunity is a curve control. So if you did not want to use a crosshair, if you need this to be outside of the body or a more specific shape like a circle or a foot shape or hand shape or face or whatever it could be, then we can use a spline curve control. So that's all this is. Spline curve controls are represented by dark blue color, similar to the blue color as a joint. But we can also use curve controls or a curve as a control to drive the motion of objects or joints in this particular point of view. So those four major terms are what we're going to use throughout the rest of this tutorial series to set up the control rig for the character. So over here on the right, I have visual demo examples of inverse kinematics versus forward kinematics, locator controls versus curve controls, and then a secondary thing called set-driven keys, which we'll get to. All right, so I've created a leg system here. So this is a hip to knee to ankle to ball to toe parent hierarchy. So this is representative of like a bipedal human leg. And one thing we can do with forward kinematics is just rotate every individual joint. But we don't have the means and opportunity to be able to do proper stepping and planting of the foot on the ground or kicking or leaning over on a foot if we just do forward kinematics. So here's where inverse kinematics comes into play. So the example on the left is my joints and just one inverse kinematic. That gives me the opportunity to pick that leg up, to do some stepping, to straighten that leg out. We can also move it side to side as well. Okay. So that's the advantage of an inverse kinematic. One control can drive the motion of the entire leg. We can take that a step further and create a couple other inverse kinematics, because this one inverse kinematic is just affecting the hip to knee to ankle. So it's not really allowing me to give motion or adjust my motion for the ankle or the ball into the toes. So this first IK is called a rotate plane IK. You see in the input it says IK RP, which means rotate plane. So that gives me the opportunity to move it side to side, forward and backwards, and rotate it from the hip point of view, which I'll come back to. So I've duplicated that same setup over here, and I have created secondary IKs for the ankle to the ball of the foot, and then another IK from the ball to the toe. So with this second one, that gives me the option to rotate the ankle with this third one, this gives me options to rotate that toe. So these second two are called single chain IKs. The difference is rotate chain skips over at least one joint. So if I select my rotate plane IK, I'm skipping from the hip down to the ankle, so I'm skipping over the knee. That gives me the opportunity to have a rotate option of the, really from the hip, but to rotate the angle of the knee. A single chain does not skip any joints, so that goes from the ankle to the ball, and a second single chain goes from the ball to the toe. So that's what we can do. We can link up different types of IKs to create more natural motion with legs and other extremities. The other thing I've done here is set up controls for the main foot and for the knee. So I have curve control down here, and I've moved the pivot point to the ankle. And when I pick up and move this curve control, it allows me to move my leg. I can move it side to side as well. And then I can also rotate the curve control, and that rotates my ankle. Okay. So the other curve control I have here is for the knee. And if I move this knee control, that pivots or rotates the hip and always points the knee in this direction. So this is another step process, and this is called using constraints. So in some of the later videos, we'll talk about how to create constraints. But with my base curve control for my leg, this is a parent constraint. And I selected my curve, and then I shift selected my IKs. So these three IKs for the leg. So the translate and rotate for these three IKs are being controlled by this curve. So hence the name control rig of why we're using that term. So basically this curve is controlling the movement and rotate of those inverse kinematics. Okay. The knee curve is a different type of constraint called a pole vector constraint that is constraining the rotate or twist of the IK for the leg, the rotate plane IK. So that way whenever I move this curve control, the pole vector rotates will change and always look at this direction. So that's kind of another step process we will go through as well, which is called constraints. Constraints allow a curve or a locator to drive the motion of a joint or an inverse kinematic. So the curve controls the inverse kinematics or the joints. All right, a couple of examples over here. I have two examples of inverse, or two examples of forward kinematics, and then one example of inverse. So this top one, I'm using simple locators. All right, so this is just three different locators. And this process is called forward kinematics and using locator controls. So if I select that shoulder, this is an arm joint system now with the fingers. If I select the shoulder locator, I can rotate that. If I select the elbow rotator, I can rotate that. If I select the wrist rotator, and I can rotate that. I can also create sub-locators for each one of the finger joints as well. So this is called forward kinematics. This is using another constraint called an orientation or orient constraint. So basically if I select a joint, you can see just the rotates are being controlled by something else. So just the rotates for this elbow joint are being controlled when I rotate my locator for the elbow. So that is using locators as forward kinematics. This next one is using curves, the same type of curves as I did for the foot. These are just circle curves, and I'm using the curves in the same way as my locators. So that way when I select that curve for the shoulder and rotate that, I can rotate the shoulder. If I select the curve for the elbow and rotate that, and the same thing for the wrist, they'll rotate the corresponding joints. Now the reason we would use curves instead of locators is if there's geometry associated with this that's too thick to be able to see beyond the locator's default settings. We can always scale a locator, but what we are going to do with curves is just scale and position the look of the curve so that it's outside of the geometry. So that's one reason why we would use curves instead of locators. This bottom example shows an inverse kinematic with the arm. So the difference is the top two do not have inverse kinematics. They just have forward kinematics from rotating each individual joint through a curve. This bottom one, I only have one control for the entire arm. And what I'm doing with this curve, is a curve control here, another circle curve, is I have an inverse kinematic for the arm from the shoulder, skipping over the elbow to the wrist. So if I select that inverse kinematic and move that, it moves the entire arm from the wrist point of view. But on top of that, I've added what's called a parent constraint. So I've parented the inverse kinematic to the curve control for the wrist. So when I move that curve control, it also moves the IK. The IKs moves the joints. What I've also done is also added an orientation constraint to the wrist joint. So that way when I rotate my wrist control, that also rotates my wrist joint. So instead of having 1, 2, 3 different controls for the arm, I really could set it up to where I only have one control for the arm that moves and rotates. Now what I would then also do is come back and create an elbow curve control, just like I did for the knee, that I can determine the rotate angle of the knee, and also have a control that can determine the rotate angle of the elbow. So there are advantages and disadvantages, or positives, negatives, for using forward kinematics versus inverse kinematics. It all depends on how that body part needs to animate. The last thing I'm going to show here is what's called set-driven keys, or what's called SDKs. So when we have a lot of smaller joints, we could come in and create forward kinematics or inverse kinematics for all of our fingers. But that's time consuming and also could be more difficult to animate sometimes. So for a lot of smaller joints that need to have very specific types of motions, like finger curl, finger spread, finger twist, thumb curl, spread, and twist, we can instead set up a more complex control system that's called SDKs, or set-driven keys. So basically what we're doing is we're creating kind of test and slider based keyframes that have more complex motion and set up in a much easier way. So I still have a curve control that I can move and rotate the wrist, but what I've also added are custom attributes. So the default object or control will have translate, rotate, scale, and visibility. So what I've done over here with the set-driven keys is set up custom attributes. And these custom attributes, one of them is called fingers curl, and thumb spread, just as some basic examples of what we can do. So with the fingers curl, if I type in a value of 0, my fingers are straight. If I type in a value of 10, my fingers will curl all the way up. So if I select my fingers curled in the viewport, middle mouse click and drag, you can see it as a smooth blend motion. It's not just a snapping. So I can curl all the fingers at once together. I could also do a separate attribute for each individual finger as well. So the pointer finger would curl, the middle finger would curl by itself. But in this occasion, I'm just setting up all 4 fingers are rotating at the same time when I animate the fingers curl. I also have a thumb curl as well. I have the default set at 5 so that I can curl it forward and backwards. Okay, put that back at 5. Then also have a thumb spread. From the top view, it kind of go up and down. Okay, I have it as 8 as default. So set-driven keys are saying on this curve control, create secondary custom attributes that then drive the motion of another object's attribute. So basically, when I do my fingers curl here, that is driving the rotates of my individual finger joints. So that is similar to constraints, but instead it is called set-driven keys, and it's a more complex way of driving animation that has more complexity to it. So those are some major terms and techniques that we'll talk about when creating a control rig for a character. One final thing that I wanted to mention is that organization and naming is really important once we get to control rigs. So in my entire scene here, I have major groups. I have one group called joints, and then all of my objects, all of my joints are grouped underneath this joints group. So I have my several different hierarchies of my arms and legs. They're all grouped underneath one group called joints. It is also important to name all of your joints, so that way you know what's what for when we're setting up the controls and also animating. I also have an inverse kinematic control group. So this is all of my IK groups. And then once I start doing constraints, the constraints will be parented underneath my joints or my IKs as well. So this is what a parent constraint or a constraint node looks like. This is what an inverse kinematic looks like. Open up my joint system here. This is what a joint looks like. And then part of an inverse kinematic is called an effector, and that's what the effector looks like that's parented underneath that joint hierarchy. So basically I create a group for each major type of object. So controls group, these are all of my controls that I've created. I have some other subset controls that are using a script that we'll get to in a later video, which is called an offset controller script. Okay, and I also have a type group. That's not important for rigging, but to represent all my type, that's what I have there. So if you have geometry, we would have a group for geometry. Now, the reason I'm showing this is that what is really important about hierarchy is that the IKs cannot be under the same hierarchy group or hierarchy joint system as a joint. The controls cannot be under the same hierarchy as the IKs. The controls cannot be in the same hierarchy as the joints. And then once you have geometry, the joints, IKs, and controls cannot be under the same hierarchy as the geometry. So create different groups for each major type of object that we're going to need. So we're going to have a group for geometry, a group for joints, a group for IKs, and a group for controls. It is imperative that you have separate groups. We cannot parent IKs, controls, joints, and geometry underneath the same hierarchy. It will not animate your character and your objects properly. Alright, so that's it. That's the goal for this video, was to talk about some overview terms and some basic techniques that we will go through in specific in the next couple of videos.